Hello everyone, this is History of Science Nights from Istanbul Medeniyet University's Department of History of Science. As you may remember that we started this meetings last year with two events. This is a new COVID era opportunity for us to be able to invite people without inviting in person, but getting their experiences into our community and having more opportunities for us to be able to listen many people from their own expertise. And this will be our first in this term. And hopefully from this moment on, we are hoping to be able to create this meeting monthly. And if we can keep up, depending on our visitors, our guest speakers, availabilities, hopefully this will be every time in different topics until the end of next term, 2012, June, if I'm not mistaken. As you may know or not, we will have nearly an hour of discussion, hopefully, and any kind of question you want to ask, you can ask using the chat room. And you don't have to wait for the end of the meeting. You can just ask questions and we'll start to try to take down and ask the questions when our meeting is about to end or in the meeting, depending on the direct relation to the question with the talk. And today, our first meeting with Professor Mohammed Abattouy from Doha, Qatar, and we are going to be talking about Al-Isfizari and the science of weights in the Islamic world. Starting with his short biography, I'm now giving the microphone to Sana. Here you go, Sana.
Thank you very much. Mr. Abattouy, it's a pleasure to have you here. Dear guests, Mohammed Abattouy is a scholar at the Arab Center for Research and Policy Studies in Doha, Qatar. He is a member of the team conducting research for setting up the Doha Historical Dictionary of Arabic and director of the GREAT project aiming at producing a global digital encyclopedia in Arabic. He began his academic career by investigating the history of science in the 17th century and specialized in Galileo's manuscripts of physics for his PhD dissertation from Panthéon-Sorbonne University. Between 1992 and 1995, he worked in the Centre National de la Recherche Scientifique and at the Observatoire de la Côte d'Azur in collaboration with French and Italian colleagues in history of early modern science. He joined as a scholar to the Max Planck Institute for the History of Science in Berlin, where he shifted his academic focus to the investigation of the history of Arabic classical sciences. During this period, he researched the history of Arabic mechanics and reconstructed the tradition of the Arabic science of weights, Ilm al-Atkal, which he reconstructed in full from manuscripts. From March 2007 to May 2014, he was Senior Research Fellow at the Foundation of Science, Technology and Civilization in Manchester, UK. Abattouy is the author of several books and more than 80 articles of history of science. He participated in numerous conferences and on history of science in Morocco, Middle East, Europe, and USA, and organized several of them himself in Morocco and in Germany. Dear Professor, you mentioned that your first encounter with the works of Al-Isfizari occurred in the mid-90s when you worked as a researcher at the Max Planck Institute for the History of Science in Berlin. You realized that Al-Isfizari's texts in mechanics, which have been hidden for a long time, represent an important yet unknown source about the Arabic tradition of mechanics, and that their publication will add new elements to this tradition. As a result, since early 2010, a research project was launched in cooperation with Salim Al-Hassani, and you published a critical edition of Al-Isfizari's Mechanical Corpus. Could you tell us about the aim and further achievements of this project?
Yes, thank you. I would like just to highlight that my work on early modern science and my acquaintance with mechanics in 16th and 17th century Italy, I mean, in its two forms, first as the traditional discipline of mechanics of machines than the theoretical aspect of it under Galileo's work and the science of motion. This, in a way, prepared me to have this kind of sensitiveness towards the Arabic mechanics when I worked at the Max Planck Institute with colleagues, which they hired me in the beginning to work on Galileo. And I remember that during our seminars on Wednesday mornings, they were editing and examining texts of mechanics, of Latin mechanics, for example, the works of Jordanos that were published by Moody and Claggett before. And little by little, I realized that behind and in parallel to this literature, there were insights in Arabic that could be very useful, and they present a new light to reconstruct this tradition. And little by little, before the end of 1996, a new research project was formulated at the Max Planck Institute, in which we made a huge list of Arabic works of mechanics that existed only in manuscripts or in partial Arabic editions. And work began by collecting these manuscripts from all over the world. And little by little, it turned out that we have something like 60, 70 works. Most of them were never edited. And historians don't know about that. In the middle of this collection, of course, came the work of Thabit ibn Qurra, which was, in a way, the beginning and the origin of this tradition, Kitab fil Qaraston, the book of, or the book and the Stiliard, with the term in the title having a special meaning because Qaraston, which was used by Thabit ibn Qurra in the 9th century, and his contemporaries, for example, Al-Jahid in his adab works, or works of literature, the Qaraston is the Arabization of Charistion, which is the Greek term for the Stiliard. And the content of the book of Thabit, in fact, they have no ancestry in Greek mechanics. Of course, we know of Archimedes' works in mechanics, and they are very formal, very developed, and mathematized and even mathematical in form about the behavior of the balances and the Stiliard specifically. But we know also that Archimedes' work, the equilibrium of planes, in which we have the theory, was not transmitted to the Arabic world, was not transmitted at all. Until now, we have no information confirming that it was known in the classical Arabic science when this thriving new science of weights was developing. So the work of Thabit established a kind of precedent to the basis or the theoretical foundation of a new departure in what we can call the physics of the machines, and especially of this model machine, which is the Stiliard. Later on, and after Thabit established this foundation, other scholars, of course, added new elements, new works, new texts, new manuscripts, and the tradition was enriched century after century and continued thriving in Arabic until the 19th century. Until the 19th century. And in the reconstruction I did, I showed by referring to the manuscripts, to their titles, to the shelf marks in the libraries, to extracts from them, translated sometimes even into English, that there is a whole rich tradition spanning a period from the 9th century until the 19th century. This is a work, a scientific work of 1,000 years. And as we will see later, we can call it an aspect of the Arabic physics, which is still missing, not only in mechanics, but also in other branches like magnetism, mineralogy, and especially the debates of natural philosophy. The missing link, if we want, in the tradition of Arabic and Islamic science until now, in fact, it is this collection of works of physics, which of which the works of Al-Isfizari, the corpus of Al-Isfizari, that I published with Salim Al-Hassani in Arabic, then in English, is a sort of central part because it was very influential in the big and emblematic work of Al-Khazini, the author of the famous book of The Balance of Wisdom, Kitab Mizan al-Hikmah, and hopefully a Tunisian scholar, Faiza Bansal, recently performed the first complete Arabic edition of the book of Falchazili. And I showed in the book published about Al-Isfizari with in an appendix and a huge collection of quotes and extracts, the locations and the parts in the work of Al-Khazini in which he relied literally over pages and pages about extracts from the work of Al-Isfizari, and some parts which were not transmitted independently in works attributed directly to Al-Isfizari. But anyway, the corpus of Al-Isfizari...
May I just cut in? This is quite interesting that, since you know this, how important it is easy for you to understand, but when we're talking about 1990s, it's not even the earlier stages of the 20th century that the Orientalism has a new approach to science in the Islamic world. They completely neglected this until the late 20th century. This is very interesting that in astronomy we start seeing things in the 19th century with the Sedilo brothers, father and son, actually translating things in French, or Karl Scheu translating things in German, but this has never been studied until very late. This is
in fact, some of the historians of science of European origin, which may be called Orientalists, but I'm not sure that this name,
phrase you mean,
historians of science, not like the other areas of classical Orientalism that we know. But historians of science of European origins, like Wiedemann, the German scholar, physicist, and historian of physics, and Franz Wopka, who, despite his name, he was French, they published some parts of this corpus from some manuscripts that they found in Europe. For example, Wiedemann worked on some manuscripts of this collection that he found in Gotha library in the University of Gotha. And they were, in fact, more interested in some fragments of Greek origin in Arabic. And they did them, for example, the famous text about the balance attributed to Euclid. In an article later, I was inclined, I proposed, and I am convinced personally that this text was transmitted in a very bad shape in Arabic, and that it was completed, I mean, edited according to the technique or the procedure of Islah, repairing and completing, and even sometimes when the expression was bad, etc., even completing and editing the fragmentary text inherited from Greek under the name of Euclid or someone else. And this happened in many occasions. There is another one, not edited by European early historians of science, concerning a text of this kind attributed to Euclid, but this time on the problem of heaviness and lightness. So there was an interest, but the real interest of history of science in some parts of Arabic mechanics was only in the first half of the 20th century, when work was done on the Latin version of Thabit ibn Qurra's Kitab al-Qaraston, which was translated into Latin. And this translation was edited even before the Arabic work was edited. And in fact, the Arabic edition published by the late Khalil Jawish in Paris in the 70s is so deficient, in fact, that we still lack a complete edition of Thabit. And if I have read, in fact, in my work on the Arabic science of weights, that when I left the Max Planck Institute, I went to Morocco, I was taken in the streets of life, teaching, doing research on other things, etc. I didn't edit yet the text.
We're still waiting it then.
Really, this should be done because it
Hopefully.
is the foundation of this.
And to give a little bit of information to those who do not know what a styliard is, because it's very unfamiliar usually, is the earliest version of what we call as the weight of balance. In Turkish, we call it kantar, if I'm not mistaken, I think.
Yes.
There's a steel or iron stick that you can actually balance things on it. So that's the styliard we're talking about, that the Thabit ibn Qurra is working on, I think, yes.
I have a PPT work here, and I have some images of the styliard. If you give me just 1 second, I will find it.
Okay, of course, yeah.
Show it online. Where is it?
I think you are allowed to share screen.
When you let's continue.
Okay, yeah.
I will find it.
We'll come back to it later. Yeah,
I found it. I found it.
Oh, very good.
Yes.
If you can just.
I will share the screen. Do you see it?
Not yet, I think. If you can.
Yes. This one. Do you see it now?
Yes, we can see it now.
Yes. So this is the styliard. The principle is this one. You have two unequal arms graduated on one side and the longer arm, and it is suspended from here, from the not the middle, but from the part near the small arm. And there is a moving weight. This moving weight is everything, because it is by displacing, by moving this coursing weight, the movable, that you can operate equilibrium.
Yeah.
This is why you can use this balance to wave huge weights. Huge parts of matter, not like the ordinary balance, which we see here on the left, in which we can wave only small quantities.
And the weights always has to be equal on the left, but the one we show,
not necessarily, because the moving weight.
No, I mean the other version requires equal weight, but this one doesn't require equal weight because you can actually move it around. Yes.
For example, this version of the styliard, Arabic styliard, Now it is in Petrie Museum in London. As you can see below, you can wave at it until 900 rattle, which means the pound, and 450 kilos or kilograms, which is a huge balance. It spans about 4 and 5 meters. And it's 5 meters in London.
Very nice. Thank you very much. Yeah. So it started with Sabit bin Qurra using this, and then continued over 1,000 years.
Exactly.
Back to the original.
Exactly. That was the first text in Arabic about this model machine, about this kind of balance. And after him, people continued working out the mathematics and physics of this machine and developing its functions and describing its varieties. And especially, there were a lot of discussion about, for example, if the displaced weight is lost, how can you reconstruct it? So there were a variety of problems of physics and mathematics. And especially, there was a huge debate about the law of the lever, which is the central part of mechanics, of ancient and medieval mechanics. The law of the lever, which is expressed here, is that there is a inverse proportion between distances at which the weights are suspended and the weights themselves.
Coming back to our original discussion, this was, you started working on this after your original studies on European sciences, and Salim al-Hassani and you translated, edited this, and then you translated it into English.
Yes.
If we come back to that, and was that the only thing? Because is it continuous? The project is continuing with different aspects, or are you still working on specific things?
Unfortunately, since I arrived in Doha, I stopped doing research on this.
I see.
This collection of texts. I am working in the Doha dictionary to setting up the Doha historical dictionary of Arabic. And now I am directing a new team to create an Arabic encyclopedia. But hopefully there will be at least half of it devoted to science. So that we can do history of science, we can do scientific culture, not only in academic research for publishing texts, editing, etc., but there could be other avenues which are very useful to people. And I think that we need an Arabic encyclopedia now devoted to science.
Absolutely.
And to the various aspects of social sciences, exact sciences, philosophy, etc. This is really something that will be probably more useful than spending several years editing texts of history of science.
Dear Professor, sorry.
Other scholars later can do that. I mean, I'm ready. if there are students willing to do that, I am ready to, I say that publicly, to give them manuscripts. I have them all on my computer, scanned.
Thank you very much.
To be shared with people so they can devote 2 years to sort out this corpus.
Thank you very much. Absolutely.
Thank you very much. I'd like to ask a more general question. You mentioned that the corpus of mechanics of al-Isfizari includes a collection of texts in theoretical and practical mechanics, the two main fields of mechanics, which are ilm al-Atkal and ilm al-Hiyal. And you describe the structure of Arabic mechanics on the basis of the sharp distinction in the Arabic classical learning between those two branches of science. Could you explain us the difference, please?
Yes. In fact, here we will mention another central figure. We began by Thabit ibn Qurra as the ancestor of al-Isfizari, or the father of the tradition of the study of Arabic works in physics and mathematics and the different kinds of stelliards. Now, we will mention another one who is a philosopher. This is Al-Farabi. Al-Farabi, who lived in the 10th century, a little bit more after Thabit ibn Qurra. He died in 339 Hijri, in Hijri. He, of course, he is known as a huge, a great Arab philosopher, author of many works of philosophy.
Yeah.
Yes. But he is also famous for authoring Kitab Ihsa al-Ulum,
yes,
the book of enumeration of sciences, in which, and it is a small book, it's not very detailed, in which he gave a classification of sciences, which was until his time unprecedented. Of course, he, as you can see in this picture in front of you, he differentiated between 7 main sciences. I mean, if we consider that the science of language, logic, metaphysics are sciences in the same way than mathematics. And then, in his characterization of these sciences, of course, there are Aristotelian, Greek influences, and new insights, etc. But what is important for us to answer your question is that he operated a differentiation in mathematics between 7 arts. These arts are known: arithmetic, geometry, perspective, astronomy, music. And then he added science of weights and the science of machines. He said, as you can see here,
we're not, apologies, we're still seeing the origin engine, I think. Did you go to another PowerPoint?
Maybe you can screen share again.
Mm-hmm.
Because if you change another document, we don't see that. You have to stop sharing and share it again for the document, I think. Still see
Can you see it or not?
No, we're still seeing. We're still seeing the
okay. I do it. I stop sharing. Then I come back. Okay.
Yes. Unfortunately, that's Zoom. It just shares the specific one that you actually shared. I can stop your share if you want. I can help you with that.
Please do it.
Let me just do this. Yes, and you can share it again.
Okay. Yes. Anyway,
yes. Now we see.
Is that Al-Farabi distinguished clearly, but between what he said, as you can see here in the first line, علم الأثقال, which is the science of weights, and علم الحيل, the science of ingenious devices or machines, science of machines, in fact, because hila in Arabic, the original sense, is not the current signification it has now. I mean, stratagem or trick. Hila is the machine. And it is literal. I published an article on that to prove that hila at that time was the equivalent, the strict equivalent of machine, as translated from Greek. So
it's not a trick, you mean? As we
it has this first meaning, but it is used conceptually in science. It means, like, for example, علم الحيل or الحيلة في هذا. It means this machine is like that, and it is described as a machine. So Al-Farabi distinguished between علم الحيل and the science of weights, and he characterized the science of weights as theoretical mechanics, in fact. This is what should be kept in mind. And he set up, in fact, a tradition, because all his followers later in Arabic philosophy and science and culture, they followed him, all of them. No one challenged this distinction. No one, really no one, because you know that after Al-Farabi, there are a sort of explosion of classifications of sciences in philosophy, in literature, in science, etc., in general culture. And all of them, when it comes to the distinction between these two kinds of sciences of mechanics, I mean, weights and the normal machines, balances, in fact, and the other machines, they all followed Al-Farabi. And it was a result on which they built until the book of Al-Farabi, as we know, was translated into Latin in the 12th century by González in Spain, in Al-Andalus. And this distinction was transmitted to Europe, and they followed it. This is why the Arab, I mean, in the questions, I saw that there is a paragraph on that later, but let me just say that. The Arabic ilm al-afqal is literally the basis and the foundation of the Latin famous Scientia de Ponderibus. And the Scientia de Ponderibus was used in Latin for the first time in the translation of Al-Farabi's book.
Oh, I see. Interesting.
And of course, it knew a huge development in early Latin European mechanics. But
it is always connected, though. I mean,
continuation of the same tradition.
And there's a little bit of Aristotelian style we can see that it starts with the theory as a mumkin, and then what mumkin can be actually practical in the sense that you actually think about it. If you talk about the science of weights, but if you want to implement that, it becomes a little bit of ilm al-hiyal then. That's the thing, yes.
Yes, exactly.
There is always a connection. That's why anyone who deals with ilm al-afqal also deals with ilm al-hiyal as well, I think. That's why there is a connection between them.
Yes, exactly. And especially the importance of this thesis or contention or theory is that the science of weights as theoretical mechanics developed hugely in Latin mechanics and continued in a thriving tradition until the work of Galileo. There was a connection between this medieval Arabic and Latin tradition and the birth of modern science. And this is a huge consequence and result. That
even with the mechanical clocks, I think, is the same.
Yes, exactly.
Very interesting.
Thank you very much, sir. I also would like to ask a contextual question. What was the driving force for works on the science of weights in the Islamic world? Was that just economical, or were there any religious, political, or purely scientific motives?
Like in every other branch of science, of course, there were social factors, because you know that the balances are intimately connected to commerce and to practical life. And it is quite normal that this artisanship and these arts of daily life are taken into consideration and theorized by scientists. That's quite normal. And the most representative book in this direction is the book of Falchazili, because Falchazili describes the theoretical part of the balances and working with balances, mathematics of balances in his, I mean, he edited and summarized in his book even the works of his predecessors. So he wrote a kind of encyclopedia of the science of weights, of theoretical mechanics. But also in the second part, he described a balance, a huge balance that can be used in different functions. Of course, to wave, to make astronomical observations, and to even calculate time, and to be used to calculate specific gravities. So it is a multifunction instrument described in detail with tables of comparison between different materials and how they relate one to the other in terms of specific gravities. There is famous أوزان نوعية or specific gravities, which is a huge endeavor in ancient and medieval science. And in Arabic and Islamic science, there are dozens of treatises of this kind, which in fact they should be included in the tradition of the science of weights and mechanics, because they are intimately related to it. And I remark also that most of these works are still hidden in manuscripts and not yet edited. Now, after saying that about the social origins of the interest in theoretical and practical aspects of the balances, of course, there was also the scientific aspect. I mean, the Arabs and Muslims inherited from the Greeks this interest in machines and in balances specifically. The book of Archimedes that I mentioned before, The Equilibrium of Plants, which is a very famous contribution by Archimedes, is in which we find the theory of the balances, and in which we find the first mathematical justification and demonstration of the law of the lever. So they inherited that in the scientific part from the Greeks, and they developed it. And the best way to answer your question is that, of course, there were social factors and others stemming from science, from inside science. And this connection between the material factors, social, coming from society, from the needs of society, and at the same time, the answer provided by science, this is the same model in many other branches of science practices.
But do you think a little bit of different than the other scientific approaches in the Islamic world? Because the mathematics takes a lot of toll in the corpus that we have. Now, astronomy, although we don't have in everywhere with the large observatories, but the Mamluks have timekeeping tradition for hundreds of years, and there are other traditions that has a lot of books that every astronomer has something written and has copied numerous times. When I try to study, because I have to study about the weights also, but it is very hard to find copies, although we have many people working on this throughout the 1,000-year period. But I was quite curious if this is helpful for economic purposes with the gold, calculating the gold if it's pure or not, which is quite reasonable to have a good scale. So why wouldn't we have more manuals, for example, how to use these instruments?
Yes, if you do the same like you did a minute ago, you stop my sharing, I will show something else concerning the course. This is the best answer to your very important question. Yes, here it is.
Mm-hmm. Not yet, I think, but if you just...
Do you see it?
Not yet, but if you can click on, yes, we can see it now.
And now?
Yes. Yes, pseudo Euclid, pseudo Aristotle.
You see it, Arabic versions of Greek sources?
Yes.
Yes, so you see in the corpus of Arabic mechanics, theoretical mechanics of science of weights, we have different layers. The first one is the Arabic versions of Greek sources, in which we find, as you see, texts attributed to Euclid, to Aristotle, to Hieron of Alexandria, to Archimedes, and to Pappus. And let me insist on just one thing, is that the books of mechanics by Hieron and Pappus are very detailed, very huge volumes of science, but while the other four ones are short texts. And of course, I am referring here, as you can see, only to the Arabic works. Some of them exist in Greek, others exist only in Arabic.
Yes, thank you. I have even a couple of copies of Hieron and Pappus as well. So, but I think my question a little bit goes the other way around to follow up, perhaps. We start seeing that Al-Fizari and Khazini are two of the most important mechanics in the Islamic world. They what they created, co-shared of invention of the Mizan al-Hikmah, was one of the most important inventions about the science of weights before the modern times, perhaps. From the details I actually learned from the manuscript. Why no one actually started to be able to, or maybe they did, but I'm not aware of that. That's what I'm asking actually. Why they didn't actually try to copy this manuscript and try to make them? Have you ever come across that people were trying to make it, but not successfully perhaps, but still trying to make these kind of instruments?
They did. Oh. Because now when we find the individual texts, sometimes we find 10 to 15 copies that survived until now. You can imagine that dozens didn't survive. Now when, I mean, history of science showed the huge corpus of Arabic mathematics, astronomy, and optics. That's now an established result, and no one can challenge it or doubt it.
Absolutely.
I can assure you, it is the same in mechanics.
I see.
The only difference is that Arabic mechanics was neglected, was put aside, was not edited, was not discussed, was not analyzed. There were some important treasures, like the work of Thabit, as I said before, the work of the Syrian, Turkish astronomer and scientist, Mohammed ibn Ma'ruf, Taqiyuddin ibn Ma'ruf, who lived in Istanbul in the 16th century, and he's very known by his different works. He published also books in mechanics.
Jazari also again.
Exactly. So, for example, his book, I don't remember the title exactly, but about Al-Alat al-Saniya. Published by the late Ahmed Yusuf al-Hassan in Arabic. For example, these sort of famous works exist, but others are still in manuscripts. Our endeavor now is that we should edit them. And of course, if they come out, then studies will begin, and we will see the richness of the content.
To go in a little bit of detail with Al-Fizari, he lived in a very interesting period of time, that in Seljuks, not just one time in Seljuks, but the best time that he could have been, actually, I think, because he was with the special group of people, astronomers, including Omar Khayyam, and he was part of the observation that most likely in what was established in Isfahan. So he was there, and we also see Omar Khayyam himself also tried to have some science of balance studies within his own works. And what kind of a time you can actually explain that why there was a specific interest in that time? Can you say a little bit more about that?
The best answer that I can provide rapidly is that when we look at the Arabic and Islamic science in classical times, the best description is that it was not the work of individuals. It was the result of a scientific tissue, a scientific tradition covering all the Islamic world, from the East to the extreme West, all of them. The science was practiced everywhere. And it was at the service of society, of course, and in the same time, it has its own scientific preoccupations and interests that was dealt with between scientists. And it has nothing to do with social needs. In this general tissue of science, there were sort of Nobel Prizes scientists like Ibn al-Haytham, al-Biruni, but there were second-order scientists also. And I may say that al-Isfizari was a second-order scientist. His work was, in fact, it prepared, in a way, the work of Falchazili, the book of the Balance of Wisdom. So when you put together the work of al-Isfizari in mechanics and the book of the Balance of Wisdom by al-Khazini, you see that in reality, it's like the master teaching his pupil and showing him the way so that he could produce this chef-d'oeuvre, which is the book of the Balance of Wisdom. In fact, in the Arabic tradition of mechanics, we can say that in the classical period, two books stand as the peaks of this tradition. On one hand, the book of Stabit that we mentioned before, and the book of the Balance of Wisdom by Al-Khazini.
All right. Sana is going to ask the last question.
I would like to ask one more question. From your works on the mechanics in the Islamic world, it's clear that the understanding of historians such as Pierre Duhem, Ernst Moody, and Marshall Clagett has to be challenged because they believe the mechanics began in Europe. So what should be the direction of studies on the history of mechanics today?
Specifically in the Islamic world, we can say, I think, yes.
It's not flourishing, but at least many texts were edited, were mentioned in studies in history of science in the Islamic world and also in worldwide, in Europe. Wherever there is interest in history of science written in Arabic in classical times, sometimes we see the interest in Arabic mechanics. For example, a scholar in Harvard, Professor Elahi Khirandish, I know that she is working and editing the Arabic version of
Pappus, yes.
Madkhal ila ilm al-Hiyal that we mentioned before. And this will be a huge endeavor because the text of Pappus is huge in content. I mean,
quite large, that's true. Yes.
Quite large, exactly. And there is a theoretical part. And in fact, now that we have also the text of Heron in Arabic, published since the beginning of the 20th century, it was published by German scholars in 1900, exactly. The only one missing from this early tradition is the book of Pappus. And if we have the Greek text of Pappus' work in mechanics, we don't have that of Heron's mechanics, which we know of only in Arabic. There is work that being done. We still need more efforts. And especially, I think that we need that sort of miracle happens so that we publish the corpus of the science of weights, because this is where the real important things lie. We have them there in manuscripts now. Many of them we worked on during my Berlin years with colleagues in the Max Planck Institute for History of Science. I remember that in 1998, we had a workshop of several days. I mean, probably even it was for 2 weeks. I edited and made copies of the Arabic texts and their first English translations. And this gave several hundreds of pages that we produced and made copies for everybody. And we were sitting in the seminar room of the Max Planck Institute reading through them. And with the knowledge that my colleagues had, more than I had, of the Greek background, and comparing and trying to extract results, etc., concerning the theoretical content and the formal structure, the demonstrations of the law of the lever, the new theorems that appear, etc. And these results, they appeared in the works we published together, many of us, by the late Peter Damerov, Professor Jürgen Rahn, myself, and other colleagues, Paul Weinig, etc. This tradition benefited a lot from the support of the Max Planck Institute in its interest for the history of mechanics. And they were open enough to introduce a small team directed by myself at the time, devoted exactly to the Arabic aspect of it. So
That's fantastic. Yeah.
They financed what we can call scientific expeditions to India, to Iran, etc., to collect manuscripts. And of course, they paid for the
travels and accommodations. Yes.
Get with correspondence and the post.
So, our Department of History of Science in Istanbul Medeni University is a rather new department. So we are actually establishing, and we're trying to put roots on different branches of sciences. And this is one of the branch that we actually have getting trouble, because when you actually start new with a student, or even you as a student, that you try to learn about things, just manuscript is not enough at some point, and you need secondary sources. And I think I have to thank you a lot about this, because most of the secondary sources is coming from you, specifically about El-Isfizari. I had to write about an encyclopedia entry in Turkish, and the only secondary sources I could find, other than the manuscripts I could actually read, was yours. So thank you very much for that. And I think we need that's exactly what we need, what you explained, that maybe not with the money that Max Planck have, or at least the investment Max Planck actually provide, but still we need a team effort, I think, because one person may not be able to handle this.
Absolutely. I agree totally. Yes.
So
I agree.
Since we cannot do this waiting people here in Turkey, perhaps that's in the beginning what we talked about, that this international collaborations brought by the COVID era might be actually quite useful, because we can now have table talks 1,000 miles away from each other, so we can actually do this. Hopefully this will actually produce some solid possibilities.
Inshallah, I will be willing to collaborate on that, and it's always a pleasure to collaborate with scholars and colleagues everywhere, and especially if we are close enough. I mean, between Qatar and Turkey, we are, as you said, miles away from one the other, and we need just to find time to discuss, to prepare, not only this kind of formal conversation in which one does not have to prepare. I went back to some of my articles. I read through them for 1 hour. And I prepared, I took also a PPT that I had. I had several of them, but I chose the one that I had presented in a technical university in Berlin in 2018, which was the last occasion I talked about the history of the science of weights.
Very nice.
But then if one has to do research, you know, but then
Of course.
there is another approach. You work on texts, you check sources, etc.
Absolutely. Thank you very much for the talk and for the wonderful summing up of a 1,000-year-old tradition for us. And before ending, we have two questions. I would like to ask them to you, if you don't mind. And one comes from Ali Isamat, says, we know that Al-Isfazari was arguing with Umar Khayyam. So what are the effects of Khayyam on his thought? He says.
Not too much. From what we know, there is a historian, an intellectual historian, contemporary to them, I think, I'm not sure. But anyway, he was very close to their time, named Al-Bayhaqi. Al-Bayhaqi wrote one of the first entries in intellectual Arabic history and Al-Isfazari. And in it, he said that they didn't, between him and Al-Khayyam, they didn't love each other.
He has seen them in person, if I'm not mistaken, right?
Yes, he met them in Balkh in Afghanistan. He met together in Balkh in Afghanistan. So when he said that they didn't come along, I'm not sure, but something in my mind now, I didn't revise on that. But it seems that the character of Al-Khayyam was not easy.
Oh, I see. So maybe they were arguing a little bit too heated, perhaps, yes.
Yes. On the other hand, the Khayyam, as we know, was more, his main contribution was in mathematics. And the huge things which are recognized now by history of science. The fort of Al-Isfazari was in mechanics.
That's true.
Al-Khayyam wrote a small treatise on a balance that I edited in an article published in Iran many years ago. But Al-Isfazari, but Al-Khayyam was more versed in mathematics and other branches, as we know. For example,
the calendar making is his trademark.
Exactly.
In that sense.
Al-Isfazari was more in mechanics. And they were colleagues, they were contemporaries. But the main important biographical aspect of Al-Isfazari, as I said, is that he was the teacher, the master of Al-Khazini. And this is a very important feature because his work prepared the way to Al-Khazini. And if I had time, because this I formulated before, but I never had the vision to implement it. There is something that we can call the Khorasan School of Mechanics.
Yes, very good name.
It includes all these people, including Al-Khayyam and others. The Khorasan School, the meaning of Khorasan, not only the region now in Iran, but more widely until Afghanistan. Because as I said, Al-Bayhaqi met Al-Khayyam and Al-Isfazari in Balkh in Afghanistan.
Thank you very much. And I have two questions from Al-Paratasoy. One says, Mohammed Abattouy, Professor, mentioned about how Arabic science of weights tradition had impact on Latin tradition. Is there any relation, or can we establish a relation about science of motion from Islamic tradition to Latin? For example, Ibn Tufail, Ibn Bajah, or Ibn Rushd, who studied motion, did have any influence on Latins?
Of course. This is known quite widely. And recognized also by historians of Latin periods. There is a huge work on this aspect by an Arabist, a historian of philosophy. Let me try to mention his name if I can recall him. He is Dutch. He published about the influence of Ibn Bajah and Ibn Rushd on Latin theory of motion.
It's a Hogendijk, you see?
No, Hogendijk is specialized in mathematics. this one, he was professor of Islamic science and philosophy
Shlomo Pines.
in Malaysia, in the International Institute
I thought to say, is it Shlomo Pines?
Anyway,
Yeah.
sorry?
Is it Shlomo Pines?
No.
Okay.
Pines is quite old for that. Shlomo Pines, yes. Shlomo Pines began this tradition of work and Arabic natural philosophy, and his contribution was quite good. And later on, now we have a huge treatises. For example, this Dutch scholar published the reception of Arabic physics, I mean the Arabic commentaries and Aristotelian physics, or Aristotle's book of physics, how it was received in Latin scholarship. And his last huge book also was the same, I mean, how Aristotle's meteorology, the book of meteorology, was received in the Arabic tradition, and commentaries were written about it, etc. So what I want to say on that is that, like I said before, a huge, the main part of Arabic physics written in Arabic in classical times, is composed of three main components: mechanics, theoretical and practical, a variety of scattered branches, magnetism, mineralogy, meteorology, etc. And the third part, which is a huge endeavor, is natural philosophy, which is precisely the physics of the ancient and medieval times. I mean, now we know what's physics since the 17th century, and there is a strict continuity from Galileo until now, from Galileo to Hawking, same path, same tradition.
Yeah.
Before that, there was something else. The modern physics inherited and erased it in a way, because it had to negate it. It was different. The modern physics erased, inherited, negated the physics of what was before it, and this was natural philosophy. And let me just give one example to show how huge this is. And for that, you have to believe me on parole. There is a direct connection, but really direct, between the concept of rope in Aristotle. Rope, R-H-O-P-E. If one can do a research on the internet to see how huge it is. There is a huge connection between rope, the Aristotelian concept of rope, the Arabic concept of mail, which means inclination, and the concept of momento in Galileo, which gave the concept of Galileo, momento, gave the modern, the contemporary concept of moment.
Yeah, the relativity and Galileo's relativity. Yeah.
Yes. So, for example, an Italian colleague, Paolo Galuzzi, began his career in 1979 by publishing a huge book on Galileo's concept of momento, which he analyzed in detail, and he showed the origins going back until the Bible, not only Aristotle. All the aspects or literature in which the different significations of momento, even in different, used with different words, and he reconstructed this tradition. But Galuzzi is not an Arabist. He just jumped all the way on the Arabic stuff and the Arabic mail, because the inclination in Ibn Sina, in Nasir al-Din al-Tusi, in Abu al-Barakat al-Baghdadi, in Ibn Baja, not in Ibn Rushd. Ibn Rushd does not have at all the concept of mail, because he was too Aristotelian. While the mail is the cradle, if you want, of non-Aristotelian physics or natural philosophy. It was really the preparation of memento. And it was inherited in Latin scholarship, and this non or even anti-Aristotelian physics developed until it was transformed into a new theory of physics in Galileo's works.
Thank you very much. Two questions I might ask from Mehmet Kocaman. The first one is the Arabic translation of Pseudo-Aristotelian Mechanical Problems, the book, a complete one, or is a partial translation?
No, I published the only small version we have. We have 2 chapters of it. I published it into a Dutch journal, edited by my colleague Christoph Luthi. We have a small part of it titled with an Arabic title. It is called Nutaf min al-Hiyal. Nutaf min al-Hiyal, which means extracts from mechanics, yes, or extracts of mechanics. This small part of the pseudo-Aristotelian mechanical problems have, we have in Arabic only the first and the second chapters, only. And there is no trace until now, absolutely no trace in bibliography works or in any other means of any presence of other parts of the pseudo-Aristotelian work.
Perhaps someday will come up, yes.
Probably, but you know, there is always this, there is echoes. If you don't have the text, yes, you have mentions in history books. But for this case, we have nothing, just this small extract. And it is now published, and I translated it also.
Last question I might ask, again from Mehmet Kocaman said, is Galileo's La Bilancetta somehow directly related to the Arabic science of words?
No, not at all. No.
It's completely different.
No. We should methodically, in Arabic, منهجيا يعني, methodically, we go with the idea that Arabic science was influential. But at certain moments, we should stop. We should stop. It stops. No influence. It's finished.
It's a breaking point. So yes.
Oh, yes.
And
yes.
Galileo is the person to breaking point for mechanical studies. Then
that's clear. You know that historians of science in Europe now, the mode or the fashion is not to believe in the scientific revolution.
Yeah.
You know, there is a huge wave of this. There was now scientific revolution. I am adept of a more classical epistemology. And for me, there was a scientific revolution. Because in the works of people like Galileo and Kepler, and later, of course,
Newton, yeah.
And Newton, okay? At least there's big names. There are others. Christopher Wren, etc. Something happened, very radical. The persistence of the same names, like for example, Newton says or entitles his work Natural Philosophy, but don't get it this way.
Yeah.
Read before the mathematical principles of natural philosophy. Okay, he's still in the realm of natural philosophy, but he is proposing the mathematical principles. Modern physics is mathematical, says Galileo. In essence, And Galileo doesn't know Arabic. He knows Latin. He turns his back to the tradition. He is aware and very proud of his, what he calls, Nova Scienza.
Yes.
The new science. He's so proud of it, and he says it many times. And we should take it on parole. If you, we can't continue talking about the influence of Arabic science in the 17th century. This is my opinion. There is no way.
Thank you very much.
Not in physics and not in mathematics. Probably there are Arabic antecedents in Descartes' geometry, the algebra.
In astronomy, we can say, because at the moment I am working in a project that explains John Greaves's work, who still learns Arabic, Persian, and even a little bit Turkish, and starts to study their understanding the medieval astronomical books in Islamic world, that he literally uses Ulubey himself in 1650s. So we still have that.
Even after that,
Edmond Hyde does that. Yeah.
Edmond Halley, he learned Arabic to read Apollonius, and he was thinking that he was going to discover jewels. This is many years doing that. But in fact, we should. I think the idea that comes to my mind concerning if we want to explain these persistences is that it is by inertia.
That's true.
The tradition continues. It's not dead yet. It continues, and like we see in the book of Le Nom de la Rose, La Nome de la Rose of Umberto Eco, that we all saw the movie, in which there is this awe surrounding the Arabic heritage, and that the secrets of science lie in Arabic writings, in the heart of the Middle Ages. Of course, we are still in the Middle Ages, but later on, with Galileo in Florence, it's finished.
It's complicated.
Kepler, how can we find the second law of Kepler somewhere? How? It's just impossible.
It's perhaps a bit unnecessary to try to match everything in the modern times to the older. It's just an evolutionary process, perhaps. So it has to come up, perhaps. So different look might be a different idea.
Yeah, probably. I mean, probably I am a traditional historian. I prefer a cutting edge. I mean, a new departure. And what we see now in our own lifetime, this huge inclination in science to begin a new beginning. And we know that we are on the edge of something very, very huge. It can come next year, it can come in 100 years, but we know it. It will be something new.
Another breaking point, you mean?
Another breaking point, exactly.
Another question, perhaps, before we finish, from Matan Kocaman says, what about Archimedes' On Floating Bodies books? Any translation of it, partial or any extract, or any interest in hydrostatics among Arabic scientists?
Exactly. Archimedes' work in statics, in mechanics, in the theory of machines, concerns the two divides of mechanics: hydrostatics and statics, specifically. So statics, Archimedean statics exists in the equilibrium of planes. And I said before that there is absolutely no trace that it was ever known in Arabic. And the reason that what the historian can present to explain this situation is that during the ancient times, I mean, after Archimedes, the treatise was so formal that it was not useful to artisans, that it was not copied. And that hopefully some copies of it stayed on the shelves in libraries in Byzantium or somewhere else. But according to what we know, it didn't circulate in the late antique times, ancient times. It didn't circulate until it surfaced later with when the Greek works were used again in European Renaissance from the 12th, 13th century. And specifically when William Mobrook edited in Latin, or in Greek, I think, the Archimedean corpus. And it was the first time that this text resurfaced, since it was dormant for centuries, for about something like 1,000 years. Now, the second part, the hydrostatics. The floating bodies exist in Arabic, but in a very short version, in which we find only the assertions, the enunciations of the propositions, with no mathematics, nothing, just a list of problems. And this was edited. This was, and it exists in a even shorter version in the Book of the Balance of Wisdom by Falchazili. So in this form, it was not very useful to the scholars. It was not useful in this form. And in the same time, in fact, the hydrostatics in Arabic did not develop a lot. And one of the best representative of hydrostatics in Arabic is the interest in specific gravities. And in specific gravities, which is a development of the Archimedean tradition of hydrostatics, we have a huge treatises existing. And I mentioned on the top of them, the work of Al-Biruni. The work of Al-Biruni, which was edited by Russian colleagues, and it is available. I don't remember the title exactly, but it has something like, anyway, even in the title, it mentions this notion of, or idea of comparison of weights, which is the hardcore of specific gravities. How we can compare the specific gravities of different materials in different media, in the air, in water, in honey, etc., according to the density of the medium. Then we can establish tables with specific gravities of these materials, with results, numerical results. And the book of Al-Biruni and this question is the most detailed Arabic work of its kind we know of.
And as a related topic, that again another question: does Islamic scholars weigh things in the water or just weigh things in the air? They use a little bit of water, I think. Khazini's, because his scale is actually uses the water, isn't it?
Yes, yes, yes. He can use. I mean, it is designed to weigh substances in the air as a normal balance with just two scales, okay? Mm-hmm. And it has a third scale, which can be put in water. So it can be used also for specific gravities.
And that's why he actually talks about hydrostatics, because of that motion.
Exactly, exactly. Yes, for him, the balance, he described it in his book, should be a multifaceted and a multifunction machine. Yes, in different media, in different situations.
Thank you very much for the answers. And any last questions, Hannah, if you have any questions?
This will be a very general question, but since we have you, I really would like to hear your opinion. We are trying to educate our students in history of physics, but we deal with this problem. The subjects of natural philosophy include subjects like zoology, biology, so we can't teach them natural philosophy as we understand. But when we try to teach them history of physics, the classical textbooks start from Galileo, so they don't include Islamic physics or Ottoman physics. So we try to collect sources ourselves, and I actually included subjects like optics and mechanics just in the context of the evolution of the concept of motion, like in Aristotle, Ibn Sina, Abu Bakr al-Baghdadi, as you suggested.
Yes.
And the concept of the structure of the matter, starting from ancient Greece and evolving in the atomism in Kalam and continuing as it's resulted in the modern atomism as we know today. So I really like to hear your opinion of how should we teach history of physics and what are the subjects we should include?
At first came to my mind the work of Petra Schroeder. Petra Schroeder, if I...
Schmidl, like.
Schroeder. She published magnetism and magnetic compasses in Arabic. She published magnetic compasses. And that was
it's German, isn't it, though? The book is in German, I think.
But the text is in Arabic, yes.
I see, yes.
Yes. She published a huge book on the subject, and before that, many, many articles. She was interested in the magnetism, the magnetic compasses, and she is now the specialist of this area. This is an important. There is also text is published on mineralogy. Mineralogy. The classical author here is At-Tifashi. At-Tifashi wrote on mineralogy, and of course there is the work of Al-Biruni on jewels, كتاب الجواهر في معرفة الجواهر. This is also a book of physics, in fact. It is on mineralogy, and there are a lot of scientific insights in it. So we have mineralogy, magnetism. Of course, we have, like I said before, the natural philosophy. In natural philosophy, you mentioned the atomism. The atomism in Arabic science and culture and intellectual endeavors is a huge, I mean, in kalam, in philosophy, I mean, almost for mutakallimin, almost all of them, they have chapters on these problems from two standpoints. The first one is sort of epistemological, a theory of causation, different from Aristotle, not using the four causes, and more enthroned in a sort of determinist conception of causation, how the cause should behave, etc. Because they rely on a sort of atomist point of view. And there is also the explanation of natural phenomena by relying on this theory. I confess that I'm not specialist of that, but in my mind, when I read, when I browse through journals, etc., there is a huge amount of literature at this aspect in Arabic and in other languages. And there is, of course, I finish by that, there is the classical Aristotelian and non-Aristotelian natural philosophy. And here we go from how the books of Aristotle, because you know, the Aristotelian physics is not only the book of physics, Kitab al-Tabi'a, but there is five books, the Cielo, the heavens, of course, the physics, the generation, and the book of generation. I don't remember the second part of the title, and the meteorology, and there is another one, I don't remember it. But anyway, since Pierre Duhem, we know that to study Aristotelian physics, we have to study the tradition of these five books. In Arabic, in classical times, there were all, I mean, until this tradition died or stopped producing, there were commentaries on these books. And of course, the most famous ones of them are done in Al-Andalus, in Muslim Spain, by, of course, Ibn Rushd, that's very well known, but also Ibn Bajjah. Ibn Bajjah, who created the beginnings of what one can call a non-Aristotelian physics. And now this is known, this is published Unfortunately, I don't remember the name of this Dutch colleague and the reception of Aristotelian physics in Arabic.
I'm sure we can find that. No?
I have it in my computer. If you give me just 1 minute, I can give you the name now.
Thank you.
Or I send it to you later.
Yeah, we might actually. It's a good way to keep in touch. So we can actually have the.
I promise I will send it.
Yeah, thank you very much.
It's very useful to know it. He published 2 books, as I said, the one on Aristotle's physics and the second one on Aristotle's meteorology, which means that there is room for a lot of research. And even some basic texts, like, for example, the large commentary of Ibn Rushd and Aristotle's The Heavens, Kitab al-Sama', it was published by Andres, the big text of Aristotle, but he published it in facsimile only. So you can imagine a lot of work. Sorry?
The author you mentioned, is it Paul Letting?
Yes,
physics
exactly. Letting, exactly. Letting, that's it exactly. And concerning Indres, he published the book of Ibn Rushd commentary on the heavens, which is a very important book of natural philosophy, because Aristotle's The Heavens is composed of 2 parts, a part of cosmology and a part of the theory of natural elements. And Ibn Rushd wrote one of the most comprehensive and detailed commentaries on Aristotle's and the Heavens, and it was published in facsimile. So you can imagine the work still needed to graph it, to edit it, to use it in analysis, etc.
Again, we need a team then.
You have there, in fact, you are young, and I hope you're the best in your coming research. You have there a generation of work, really, 20 years.
Thank you.
If this work goes until the end, you will put on the table Arabic physics, or at least Arabic natural philosophy, which we now our knowledge of it now is very fragmentary.
So each year we'll reschedule our courses because we will learn new things. So we will have new things to tell for the students, I guess.
Yes.
Yes, hopefully, yeah.
And if you can, you and your colleagues, one of the ways to progress on this path, like colleagues do everywhere in the world, and especially that you have an established Department of History of Science, is that you give to ambitious and good students dissertations on these subjects. There is no better way for a student to train himself in this not very familiar area. It demands to know languages, I mean, to have a background of history of science, history of philosophy, to read literature in different languages, etc. But if he does it, he is sure that he will grasp the craft, he will take it, he will have it in his hand, and do original work also, because he will deal with new texts, with new results. So when he is published, when he publishes his dissertation, when he begins publishing articles, what he produces is very, very original. And of course, it attracts attention. And this influences very positively his career.
That's right. Thank you very much.
Thank you very much.
And thank you for all your explanations and talk and answering questions. This was absolutely such a joy for us, and very helpful for us to understand many things that we actually couldn't put together.
It was a joy for me too. Thank you very
much.
much.
And knowing that you are actually suffering from the effects of the 3rd vaccine.
Alhamdulillah. Alhamdulillah.
That's very good.
That
Talking
when
is
we
a-
began, when we began, it stopped.
That's very good. That's fantastic to hear. So get well soon still. So hopefully everything will be fine for you too. And yes, thank you very much. And everybody says thank you. So and this is it for us. And thank you for joining us. And hopefully we'll continue these conversations in different potentials like this,
Inshallah.
or maybe in person some quite time, maybe not in short time, perhaps now the Omicron, but still this will be happening, I'm sure, because you're right. Qatar is not that far away, and Turkey is not far away from Qatar.
Yes.
Inshallah, we'll be seeing each other then.
Inshallah.
Thank you very much for that.
Thank you so much. It was my pleasure to talk with you and to remember all this tradition of work and things which are very close to my heart. Thank you very much.
Thank you. And so this is it. And we will be meeting next month for another talk. Hopefully, if nothing happens with the tornadoes or any kind of problems that stops us having this kind of a meeting, we'll be talking about the Newton's non-scientific works with Christian Schild. So we'll be expecting all of you for that one as well. And this is for us in Istanbul. We are saying goodbye to you all. Thank you very much for coming and joining.
Thank you. Bye-bye.